Hey class, welcome back to Business Statistics. This is the sixth video for Module 3. This is called 3.6 Using Complements. Yes, so we'll just get right into it. The complement of an event, if you're following along in your companion worksheet, go ahead and write in the definition here, refers to the collection of possible outcomes for the experiment that are not part of the event. So just when you hear us say the probability of A, well, this would be referring to the probability of not A, okay? I think it's a fairly easy concept. It's just not whatever it's just not whatever experiment you're talking about or not whatever event you're talking about. So we'll just go ahead and get right into the examples. I think it's a pretty straightforward concept. But nonetheless, let me know if you have questions. And let me go ahead and write our formula down here. I'll write it in green. So it's the probability of A is equal to 1 minus the probability of A complement. That bar over there means A complement. So that P should just be a normal P. There's nothing funky about that or anything. Okay? So go ahead and get into the example. Two fair coins are tossed. What is the probability at least one of the coins lands on heads? Okay, so there's kind of multiple ways to calculate this, but we're specifically looking to calculate it via using our complement formula. So if we want to know the probability that at least one of the coins lands on heads, we should calculate the opposite of that and then just minus it from 1. So the opposite of at least one of the coins landing on heads, at least one of the coins landing on heads is going to be both of the coins landing on tails. Okay, so let's first find out, well, what's the probability that both land on tails? Okay, well, that's just going to be, those are independent events, right? It says 1/2 times 1/2, which equals 1/4, or 0.25, right? So now, if we just want to find the probability of A, so the probability that at least one is heads, at least one heads, bad writing, that's just equal to 1 minus the probability that they're both tails. Or 1 minus 1/4. Disregard that, equals we'll say equals 3/4 or 0.75. Simple enough, right? So we're minusing off the complement. We decided that the opposite of at least one of them landing on heads is that they both land on tails. So we calculate the probability that they both land on tails, which we said is 1/4, and we just minus that off of the total probability. So 1 minus 1/4 is equal to 3/4, or 0.75. And so then that's going to be the probability that at least one of them lands on heads, okay? So we're going to go ahead and do a U-try. So go ahead, pause the video, and try it out on your own. All right, hope you guys had a chance to pause the video and try that out on your own. Let's go ahead and do it. A pair of dice is rolled, so a pair, so two different dice. What is the probability that at least one die lands on a 1? So we're going to do this the exact same way. Okay, so at least one of them lands on a 1. Okay, so the way that we're going to go about this is going to say, well, what's the opposite of that? The opposite is that neither lands on a 1. Okay, and we know that the probability that neither landing on a 1 is going to be, so first of all, one of them not landing on a 1 is 5/6, right, because of the 5 other options. Well, the probability that both of them don't land on a 1 is 5/6 times 5/6, or 25/36. Okay, so then we know that the probability that at least one of them lands on a 1 is just going to be 1 minus this probability, or 11/36, or 0.30555 repeating. That's that, guys. Alrighty, well, I hope you enjoyed this video. Fairly simple concept of complement. Yeah, but if you have questions, let me know in the discussion board. Shoot me an email. Get at me. All right? Sounds good. All right, thanks so much, guys.